So how do we build the amortization schedule for a 3-year, $1,000 amortized loan with an interest rate of 5%? We're going to do this in either Excel worksheet or a Google Sheets, which is later on easier on both sides to share with other members of our team. If we're sending any reports, we can control how we share and send certain different levels of authorization. So let's call this, for example, untitled spreadsheet, save. So here you can see, you can share this with any person you want, and then you can specify if you want them just to be restricted, or anyone with the link can then become only a viewer, a commenter, or an editor. So you can invite 5 different people and put in 5 different roles for them. And then you can copy this link and share that link with them, or you can put their email here and it'll automatically send them that email with a notification update. So let's start basically by inputting the information we have at hand. So we start with N, which is the numbers of periods or years. In this case, it's 3. Then we have our interest rate. We can either put R or use the same language as a financial calculator. We can do I over Y, so interest over year, and that would be 5%. Then we have the present value, which is the $1,000. And we can input that either as simply 1,000. We can specify that this is in dollars. We can click on this button right here. It can give us 2 decimal points. We can control that with these 2 buttons, so we can push it back, and then it'll be $1,000. Or I can simply do shift and number 4, 1, comma, and then 3 zeros. It's the same thing. All right. We have EMT for payment, and then future value. Okay, so again, the borrower needs to make 3 payments. Interest is 5%. The present value of the loan today is $1,000. The future value after 3 years, basically we will have paid 3 payments, and the balance for that loan will be 0. So if we want to solve for the required payments each year, let's use one of the functions or formulas. We'll start with the equal sign. We will use the PMT, and you see it right here, basically. We'll open the bracket. First, we'll start with the rate, comma, the number of periods, which are 3, comma. Then we have the present value, comma. You can either put for that future value, either click on it or just put 0 straight and then close the bracket. If I click enter, we see that it's giving me the payment amount of $367.21. You see that this is a negative amount, right? Remember, a negative cash flow indicates that this is a cash outflow or a payment. It's leaving our bank account or pocket, basically. So basically, on the loan date, you will get $1,000 from the bank loan to you. And after that, every year, you have to make a loan payment. So that's why it's a cash outflow. All right, now let's start creating our amortization schedule. So the amortization table or schedule, it just shows you the payment amounts and how to decompose each payment into 2 components: principal payment and the interest payment. So let's look at how to construct that and put it together. So the first column will be years, and we'll have year 1, year 2, and year 3. Then we'll have the beginning balance. So the first amount that we received, which is the principal at the beginning of the first principal, that was 1,000. Oops. Second column would be I over Y. or let's call it interests, right up first. So the beginning balance was $1,000, and every year we're gonna pay 5% of interest on that principal. So let's multiply the two. Again, we have C12, which is the beginning balance, times the 5%, and I just click enter. We see interest is $50. The next column, we will put the actual payment. Let's label it as PMT. And again, we know that it is 367.291. But remember, when we enter the payment, we want to do it for calculation purposes. So we drop the negative sign, because otherwise it'll be looked at as something that's being credited to us by the bank. So whenever we are working with the amortization table, make sure that your payment amount is put in as a positive number. So next column is the principal reduction or repayment. So basically, in the first payment, you're paying back $367.21. From that, $50 is $50, right? So basically, with the first payment, you are paying not only the $50 interest, but also you're repaying part of the principal. So let's say how much principal we're paying back. That would be the difference between the payment minus the interest that you're paying, which is $317. So basically what this says is in every $367 payment, you're paying $50 in interest and $317 in principal towards getting the bank their $1,000 back. So the next column, which is the last one, would be the ending balance. And basically we calculate that by subtracting the beginning balance, what we started with, minus how much we already paid so far. That would be the ending balance. Now, with that said, basically, just like we know from previous accounting understanding and knowledge, we know that the previous year's ending balance is next year's beginning balance. So last year, last year I was left with a total balance of $682. I started off with 1,000. I paid $376. Now I'm left to pay $682. So when I start the next year, I'm starting with last year's ending balance. So I'll just refer back to that. Equal this year. I'll click enter. Now I have the beginning balance for the second year. Now, what's the interest for the second year? I will simply take this number. I'll just do this times the interest rate. Click enter, and that is the interest for the second year. Now we're back to payment. I can either put in the number automatically. So 367.21, since it's the same payment every year. Or if I delete that, I can click on this box right here. I see this, there's a small dot in the lower right corner. So I can just click on it and drag down. It'll just duplicate that. Again, we said the principal reduction was the payment minus the interest. Enter. Let's just make sure we're following the same to this amount. And now when you're using such tools, you see that it tries to help you to be more efficient. So if I click on because this is a formula basically, when I click on this cell and I use the equal sign, it tells me, do you want to do the same thing you did in that cell above, which is to, let's see, it's C13, which is the beginning balance, minus the F13, which is the principal reduction. If I want to use this same formula, I can just press tab and it will just duplicate it. So time and time again, we'll be more efficient and more accustomed to using these tools. But what I want you to know is sometimes these tools are not super accurate. Sometimes we want to do something different. So just make sure that when you're using it, you know that you're 100% confident that this is what you want to do. And I'll give you an example about that in a second as well. So now we see that the ending balance for the second year is $349. This will be what we start off the third year with. So equal sign, refer back to that cell, enter, interest equals this principal times 5%, enter. Yes, okay. Now let's drag this down one more time. Principal reduction equals, so it's asking me, do you want to subtract the payment, the interest from payment? So let's do tab, and it's asking me if I want to do the same thing here. I'll press tab. And we see that basically after 3 years, our last payment is 0. So now I have completed the loan repayments in a timely manner, avoiding any inflated interest rates, because if you don't pay on time, of course, there are caveats, penalties in place that will be charged on your account. And we can see that the very last payment amount is actually equal to the future value of that loan after 3 years. Now, when we talked about the previous point of using formulas and referring back to cells, one of the main points that I can think of that is very important is going back to this interest rate right here. So here we see that this is referring back to cell C6. But if I go ahead and just drag back this cell right here, drag it down to duplicate it, we see that the second year interest payment changes from 34.14 to 600,082, whatever the number, 682,000. Now, this is because basically what happened here is Excel looked at this formula and it thought, okay, so in this cell, you're referring to C6. So I'm assuming when you go a row below, you're going a row below here as well. So it's taking the $1,000 line item instead of the 5%. So what we have to do when we're referring to a specific cell, we need to make sure that we freeze that cell so that whenever we're manipulating the table, that cell stays constant. And we do that by using the $sign. So if I go before the C and create this $sign right here, and then go before the 6 right here, and we put another $sign. If I press enter, it doesn't change the $50 amount, right? But if I drag it down, then we're back to that $34.14. So this is just to help us be more accustomed to referring and referencing different cells. And this also helps us when we're working in a project and want to do scenarios, for example. So I want to see what happens if we work with a 6% ratio. So I can then change the 5% to 6, press enter, and then it will give me the repercussions of that change, basically. I can do the same thing with this cell, for example, the starting cell. I can say it equals this cell, but when I go further down, I don't want it to change. So I freeze it with a $sign before the column and a $sign before the row number, press enter. So even if I drag this down however many times or years, it will always be 1,000. So now let's try to do it again and try to see how we can be more efficient with it. So let's take these back again. I will copy them and paste them here. Years we said 1, 2, 3. Beginning balance is right here. Tab. The interest equals this cell, and we want to freeze it. Payment again, we can either reference this cell, but we will have to put a negative sign in front of that to invert it, or we can put it in manually at 367.1. The principal reduction, we said it was payment minus. Oh, sorry. We said this is the principal times interest rate that's frozen. And again, see, when you try to rush it, sometimes you'll mistake. So try to be as accurate as possible. Okay, so the principal reduction is the payment minus the interest, and basically the ending balance is $1,000 minus how much we paid. Now, if I enter that this is the beginning balance is last year's ending balance, click enter, then I can go ahead and drag this down. It's going to be empty because this here is empty. And then I'll drag this down 3 cells. This is 0 again because nothing has yet been calculated. Okay, so let's do 2 decimal points. Payment is same thing. Since it's entered manually, it's not going to change. The principal reduction will change based on how much interest we're paying. And here, interest is still 0. That's fine because we haven't yet calculated the ending balance. So if you go to the ending balance, we'll drag it down, we see that once this was dragged down, it calculated the ending balance for the second year, and then automatically it sent it to the third year as a beginning balance, and it calculated everything else from there. So the more practice we get, the easier things will become. And then it doesn't hurt for us to do some aesthetic stuff. So make sure that this is separate from this. If we're presenting it to someone, to our team, to our decision makers at a company, it doesn't hurt for us to represent the envelope colors. I'll do white, bold, just to make sure that this is differentiated from the first one. Let's do this as a whatever this color is. Change the phone number, the phone color, and then make it both of them. So again, this is how we're able to build an amortization table. And this is for presentation purposes. So I also encourage you to use that whenever you're delivering any of your homeworks and your assignments, or if you're doing any presentations in your professional setting. So think about that. Think about how to present those numbers and make it easier to digest as well.